I'm going to work through some of the odd or the even problems in this case, and um, hopefully everything we do today is sort of just review. Um, some of the things seem a little bit tricky, but you should already know how to do that. I think you just need a couple refreshers. So you're going to do unit circle. Yes. Um, so look at number 38. The sine of negative 270 plus the cosine of 450. How can we make this problem easier? Ooh, no, yeah, because we're dealing with sines and cosines, and because we're dealing with the unit circle, this angle and this angle, they don't interact at all. Right. We want to change the angles to create an angle that's within one positive rotation. That's a lot easier to deal with. So what would you do to 270? Add 360 and you're going to get the sine of 90 degrees. Right? Okay. Plus the cosine of, you're going to subtract 360 to get it within one rotation, and the cosine of 90. Okay, so on my unit circle, we're right here, 90 degrees. This point is 0, 1. And sine is the y value, and cosine is the x. And the way I remember that, cosine equals x and sine equals y. When these are in alphabetical order, these are in alphabetical order. That's kind of how I just keep it in my head. Or if you preferred the wall and ground story, sine is the height of the wall and cosine is the length of the ground. So what is the sine of 90? 1. So this is 1. What's the cosine of 90? 0. So the answer is 1. Okay, let's do another one. The cosine of, oh, sorry, this is number 40. The cosine of negative 720. Now I don't want to use 720. So I'm going to add 360 and then add 360 again, and I'm going to get the cosine of 0. Plus the tangent of 720 is also 0. Does anybody not understand that? Okay, so we look at our unit circle, 0 degrees. That's 1, 0. So the cosine of 0 is 1. And the tangent of 0, how do I find the tangent? It's y over x. Tangent is sine over cosine. So that would be plus 0 over 1 is 1. Now, you might ask, why do we care? Well, we really don't. We're just practicing using the interaction between these ratios, because in the future, you're going to want to be able to simplify things to make your problems easier or to make the solutions make more sense. So we're really just practicing trig here. We're not really solving anything that's useful at the moment. Okay, 42. The sine of negative 5 pi over 2 plus the cosecant of 3 pi over 2. Let's look at this first angle. Where does that first angle land? So we're going to rotate backwards. How far is it to here? That's negative 1/2. We'll do both. You can. So this would be negative pi. That would be 3 pi over 2. 2 pi. That would be negative 5 pi over 2. Okay, and that point is 0 comma negative 1. Now, if you don't like doing that, you can always reverse the angle. What would I do to negative 5/2 to turn it into the smallest positive angle I can? Add 4 over 2, or 2 pi. So negative 5/2 plus 4 over 2 is negative 1/2. Add it again, and we get 3 pi over 2. Well, it doesn't matter. All we care about is finding where we stop. So if you graph negative 5 pi over 2, you end up on the negative y-axis. If you graph negative 1 pi over 2, you land in the same place. If you graph this, you land in the same place. So it's just whatever method you prefer to figure out where you stop is what you're going to do. Now, I'm not sure if these are all going to land on the same place. I'm not really sure why they would want you to do that. Not that it really matters. But so far, they've all been the same angle, right? Yeah, I don't know if you can trust that or not. In my mind, it doesn't make any sense to always do that, but whatever. So the sine of negative 5 pi over 2 is negative 1. And then 3 pi over 2 is the same angle, but it's the cosecant. What is the cosecant? It's just the reciprocal of the sine. So it's negative 1 upside down, which is 1 over negative 1, which is still negative 1. So it's actually negative 1 plus negative 1, which is negative 2. Okay. 44. 44 says the secant of negative 3 pi plus the tangent of 3 pi. Where is negative 3 pi? It's the same as pi. Yes. So it's the negative x-axis. It's right here. And that is negative 1 comma 0. So the secant will be the reciprocal of the cosine. And the cosine at pi is negative 1. So you flip negative 1 upside down and you still get negative 1. So this is negative 1 plus the tangent of that same angle, 0 over negative 1, which is 0. So we get negative 1. Okay. Okay. All right. Look at number 48. Determine whether each statement is possible or not. So number 48 says the cosine of theta is equal to 1.0001. Can that happen? Jimmy says no. Why not? Well, let's make it a fraction. And let's draw a triangle. Here's theta. So this would be adjacent and hypotenuse, 1.0001 and 1. Not possible, because the h has to be bigger. So what can the cosine equal? 0 to 1. When you're a sophomore, 0 to 1 is true. But now we We moved beyond that last year. It can actually be anything from -1 to 1. Once you introduce the unit circle, then you can have negative values. So the cosine of theta is sandwiched between 1 and -1. What about the sine? That's the same, right? Because h has to be bigger than both O or A. Okay. Now, what if we flip those upside down and we talk about the cosecant? So the cosecant matches up with the sine. What can the cosecant equal? The reciprocal, which does, it's basically everything else. The cosecant can be as small as 1, right? Or the cosecant has to be less than or equal to -1. Because that's A over 8, or sorry, H over A, right? So if I draw that same triangle, and I have theta, and I have A and H. Oh, sorry. There we go. It ends up being the same for the secant. I just said it wrong. What do we know about H? It's bigger than O, except in the really weird cases where they're actually the same size, right? Like at 90 degrees or 0 degrees. Okay, so H divided by the opposite has to be bigger than 1. Or in the negative case, it has to be smaller than -1. Okay, and you can see that in your calculator. If I try to do the inverse cosine of 1.2, I get error because it can't be that big. But if I do 1 divided by well, that's not, let me not confuse you that way. So take a look at number 50. Can the sine of theta equal the square root of 2 over 10? 50. Why? Exactly. That's O divided by H, and the square root of 2 is smaller than 10. Can we build a triangle where that happens? Yeah. Okay, 52. The cotangent. Can the cotangent be the negative square root of 6 over 7? Yes, because A and O can be anything. So can you ruin a tangent? You can. At 90 degrees you can, because you get 1 over 0. So in the unit circle, this one is 0, 1, and this one is 0, -1. So the tangent of either of those is going to be 1 over 0 or -1 over 0, which doesn't exist. Right. So cotangent has problems at 0 and 180. The tangent has problems at 90 and 270. So good. Good observation. Okay. 50. What are we on? 54? Can the cosecant of theta equal pi over 2? Right. So the cosecant would be h divided by O, and pi is 3.14 divided by 2. That works. Okay, does everybody understand how we're figuring these out? And 56. Can the secant equal 0.9996? No. The cosine can, but the secant cannot. Okay, pretty simple. All right, 58. Find the answer exactly. So 120 degrees is right here. And this is -1/2 comma √3 over 2. You're looking at your unit circle. Cosine is the x value. So the answer is -1/2. You guys remember this? What if it asked for the secant? So one way to look at it is 1 divided by negative 1/2. That's a little confusing. Or just flip the fraction upside down, negative 2 over 1. Okay. 60. Sine of 7 pi over 4. Where is 7 pi over 4? It's in quadrant 4. So right here I have root 2 over 2, negative root 2 over 2. I want the sine value. The sine is the y value. So negative root 2 over 2. Okay. Let's do tangent. 210. 210 is in quadrant 3. And the values are 210. So it would be negative root 3 over 2, comma, negative 1/2, right? How do you find the tangent? So you do the y divided by the x, which is basically just the y times the reciprocal of x. So negative 1/2 times root 3 over 2. Oh, oops. 2 over root 3. 2's cancel, negatives cancel, and I get 1 over root 3, which is really root 3 over 3. There were 2 negatives. Because remember, all suckers take calculus. So my tangent answer in quadrant 3 has to be positive. All right, 64. I don't like negative 330. So just add 360 and you end up with 30 degrees. And the secant of 30 is the same as the reciprocal of cosine. Cosine of 30 is root 3 over 2. So I take, sorry, let me draw this. I'm going too fast. So I end up here, 30 degrees, root 3 over 2, that's the x value. I flip it upside down, 2 over root 3, but I can't leave root 3 in the bottom. So it's 2 root 3 over 3. Okay? All right. Look at 70. So it tells us that the sine of theta is root 3 over 2. And the question says, find all possible angles where that happens within one rotation. So you can see it gives us a domain, stay between 0 and 360. So in this rotation here, how many times do I hit a y value of root 3 over 2? Twice. Where does it happen? So right here, well, that's kind of it's a bad drawing. Right here, I get something comma root 3 over 2. And then it happens again here. Why not in quadrants 3 and 4? They're negative. So the answer is 60 degrees and 120 degrees. Now, these are actually pretty easy because all of the answers are on your unit circle. Okay, take a look at 72. How many times does the cosine of theta equal negative 1/2? Twice. Which quadrants? 2 and 3. What's the angle in quadrant 2? 120. And the corresponding angle in quadrant 3? 240. Now, why doesn't it happen in quadrant 1 or quadrant 2 or 4? Because the x values are positive on that side. Okay, does everybody understand? Okay, and 74, the sine of theta is 0. 0 and 180. Okay, and then 76, the cosine of theta is negative 1. Just 180. How come we don't have 2? That's the only negative one. Okay, it's sort of like the cosine is negative in quadrants 2 and 3, but -1 does not land in either of those quadrants. It's actually right between them. It's sort of the minimum value cosine ever reaches. Okay. Last section. 78. The cosine of theta equals 0.701 or 7071, and the terminal side of theta lies in quadrant 4. Find the smallest possible measure of theta if the indicated information is true. 78. So, where am I? We're in quadrant 4, right here. And I want to know the cosine of theta is equal to 0.7071. What is the angle? Meaning, how big is that angle there? Okay. How would I figure this out? So I could take this triangle here and say A over H. So I could say 0.7071 and 1. Or, really, I could just invert the cosine. So cosine inverse of 0.7071 gives me 45, just over 45 degrees. Okay? So this is 45 degrees, which means this is 360 minus 45, which is 315. Okay? All right. Number 80. The sine of theta is equal to negative 0.1746, and we are in quadrant 3. Well, if I invert this, it will tell me this angle right here. So I take the sine inverse of negative 0.1746. Wait a minute. That doesn't do us any good. Right. Why do I want to take the positive? If I just had a triangle here, can any of those be negative in a regular triangle? No. So this negative really doesn't do anything other than it tells me which quadrant I'm in, right? This side length right here is negative 0.1746. But when I'm looking for this angle, the negative doesn't matter. So I'm just going to invert the same thing without the negative. And I will get 10.05 degrees, which means the answer is 190, because I'm in quadrant 3. So I need 180 plus my theta. So you will need to draw that picture, because sometimes you'll add, sometimes you'll subtract, just depending on where you're landing. All right, 82. We're in 3. So we're right here in quadrant 3, and we have the cosine of theta is equal to negative 0.3420. So I'm going to invert the cosine of, why not the negative? So basically what I'm doing is taking this triangle and removing it from the unit circle, which means all the side lengths now become positive. And then I can use my A over H to calculate theta, and then I take that angle and stick it back in, and I'm going to add it to 180. But watch what happens if I don't get rid of the negative in this case. The negative cosine, the cosine of negative 0.3420, and it gives me 109 degrees. That doesn't make any sense, right? So here's my triangle right here. Can this angle be 109 degrees? No, which is why I need to get rid of the negative. Because when I invert the cosine, I need a number that's smaller than 90. Do I dare tell you? I'm not sure you want to know. So this angle is 70. What do I do with 70 degrees? Add it to 180. Okay. What if I was in quadrant 2? What would I do? Nope. If I were in quadrant 2 and I found out that this angle was 70 degrees, I would do 180 minus 70. So that 109 does mean something, but I don't think it's worth frying your brains over. It can be used, but you have to be really, really careful. So I wouldn't do it. I would just get rid of the negatives. All right, we need to do a tangent. 84. The tangent of theta is 11.43. Wait a minute. Can tangent be bigger than 1? Yes. Yes, because it's an O and an A. It doesn't matter. Can tangent be less than 1? Yeah, the only thing tangent can't be is 1 over 0. Okay. And in 84, we're in quadrant 3 again. Always 3. Okay. If I was working a tangent problem in a different quadrant and I ended up with a negative, do I just get rid of the negative? So let's say I was in quadrant 2, or plus and minus. Would it be okay just getting rid of the negatives? Yes, because it's like lifting that triangle off the unit circle, and then the negative side becomes positive. But in this case, why is tangent positive? We're in 3, and in 3, they're both negative. O and A are both negative. So, okay, we're going to invert the tangent of 11.43. And I end up with 85 degrees. What do I do with that 85 degrees? Add it to 180. What if I was in quadrant 4 and I found out this was 85 degrees? Subtract it from 360. What if I was in quadrant 2 and I found that to be 85 degrees? Subtract that from 180. Yeah, and if you're in quadrant 1, then your answer is just your answer. I don't think that's going to happen, though. Okay. Pretty simple assignment. I think you guys can handle this. Oh. Did I? Oh, sorry. It should be 37. Sorry, 37. You're starting on 37. Let's do a secant problem. Let's do 88. I didn't realize they snuck it in on the last page. So the secant of theta is a negative pi, negative 3.14. And we are in quadrant 2. Can this happen? Does this exist? Yes, because h over a has to be bigger than or equal to 1 or negative 1. Okay, so how do I invert the secant? I don't have a secant inverse button. Flip what? So the secant of theta is 1 over the cosine. But if I did 1 over the cosine inverse of negative 3.14, you cannot plug 3.14 into the cosine. It won't let you. It's too big. So instead of flipping the cosine, why don't we just flip the number? So, this should work, but our calculator won't let us do it that way. So instead, I'm going to do the cosine inverse of 1 divided by 3.14. Well, it's actually the only way to do it. So the secant is h over a, right? So that's 3.14 over 1. But I don't have the button that will undo the secant. All I have is the cosine button. So I have to do the cosine inverse, and I'm just going to take this and flip it upside down. And can I just get rid of the negative again? Yes, getting rid of the negative just removes the triangle from the unit circle. Yeah, if you're doing inverses, yes. The only time a triangle can have a negative side length is if it is positioned in the unit circle and you're in quadrants 2, 3, or 4. No other triangles have negative side lengths. So by getting rid of the negatives, all we do is take that triangle out of the unit circle and then solve for the angle, and then we put it back in. So the cosine inverse of 1 divided by 3.14 is 71. What do I do with 71 degrees? Subtract it from 180. Now, we do have a cool button on our calculator that will reciprocate anything we want. So if I type in the cosine inverse of 3.14, and right under the matrix, you see x to the negative 1. That button will flip anything you want upside down. And I get 71. So, for instance, let's say I had 0.75, 3/4. What is 3/4 flipped upside down? 4/3, which would be 1.3 repeating. So if I reciprocate that, or I reciprocate that, that button will just flip fractions upside down. And you can see that it just keeps doing the same thing over and over. So if you ever want a little bit of a shortcut, you can just push it's called the inverse button, but when you're dealing with numbers, it just reciprocates them. Okay? All right, I'll change this. It should be 37, right? 37 to 89 odd. Okay. Good luck.